So last year's exam, number 4, this is the significance test from 2019. It says tumbleweed, commonly found in the western United States, is a dried structure of certain plants that are blown by the wind. Cachia, a type of plant that turns into tumbleweed at the end of the summer, is a problem for farmers because it takes nutrients away from soil that would otherwise go to more beneficial plants. Scientists are concerned that cachia plants are becoming resistant to the most commonly used herbicide, glyphosate, or however you say it. In 2014, 19.7% of 61 randomly selected plants were resistant, and in 2017, 38.5% of 52 plants were resistant. Does the data provide convincing statistical evidence at the alpha equals 5% level that there has been an increase in the proportion of plants that are resistant to the herbicide? Now, just by first glance, remember 19.7, 38.5. Yeah, it looks like it's going up. Is that big enough of a difference? So we'll start off by stating our hypotheses. Let's state the null. Let's say that the proportion in 2014, let's assume nothing's happening, it's equal to the proportion in 2017. And alternatively, we're trying to see that if in 2014 less are resistant than in 2017, where P sub 2014 is the true proportion of cachia plants resistant to the herbicide, and where P 2017, in 2014, and where P 2017 is the true proportion of cachia plants resistant to the herbicide in 2017. So we're trying to see if that has gone up, the amount resistant. So in 2014, is it less? So next up, what do we got next? So we have our phantoms, so parameters, hypotheses. All right, we could set an alpha level. You can do it later when we name it, but let's check our conditions now. So we have conditions. So we'll do 2014 first, okay? The plants were randomly selected. Yeah, that's true. 10 times, what was it in 2014? 61, which is 610. Is that less than all cachia plants? Yeah, that's safe to assume. Therefore, independent. And then 3, remember we have to check NP greater than or equal to 10, NQ greater than or equal to 10, and we're going to use the null since we're assuming that it is true. So 19.7% or 0.197 is your p hat here. We're using the p hat of 2014 because we don't know the null. Okay, so we have 61 times 0.197 and 61 times 0.803. And both of those should be greater than or equal to 10. And let me just quickly do that. 61 times 0.197 and 61 times 0.803. And we get 12 is greater than or equal to 10, and 49 is greater than or equal to 10. Good. Okay. Therefore, the distribution will be approximately normal. All right, I know I'm taking a lot of room. I'll just shrink it down after. And then in 2017, we have the plants were randomly selected. We have 10 times 52. Same, right? Don't do this on your test. And then 3. same thing. We're going to check n p hat greater than or equal to 10 and q hat greater than or equal to 10. In this case, you have 38.5% of 52. So it's 52 times 38.5. Is that greater than or equal to 10? And so on. And therefore, the distribution will be approximately normal. And then really what I want to do here, let me just shrink this down first. Then we have to make the statement, therefore, the distribution of P 2014 minus P 2017 will be approximately normal. Okay, so now let's go ahead and name this thing. We have a 2 proportion Z test at alpha equals 0.05. And I'm going to go ahead and enter the information into my calculator. So stat test 2 proportion Z test. And we've got, let's see. So 19.7% of 61 means that for x, I'm going to put 12. Remember, you have to put an integer. So that's important because if you remember what the screen tells us, it says x1, n1, x2, n2. You can only put integers for these. So what I'm going to put into x1 is I'm going to do, and we did this already in our condition, I'm going to do 19.7% of 61, and it comes out to nearest whole number 12. And n1 is going to be 61. x2 is going to be 49 because that was the 38.5% of 52. Oh, sorry, I lied. That's not it. I have to do that actually. 0.385 times 52, 20.02. So I'm going to put 20 out of 52. Okay. Now remember, don't write this down on your test. This is just me showing you what you guys are going to put in 2 prob Z tests. So we got 12 out of 61 and 20 out of 52, and we're going to do less than. I'm going to calculate it. Okay, now what are we going to write down? Well, we're definitely going to write down our test statistic. So we get Z equals negative 2.2095, and we get a P value of 0.0136, and also they tell us the p hat combined is just the p hat is 0.283. Now remember, you don't need to show this technically. It's being used when it gets the test statistic. It's using that combined p hat, but it's there for us to have. It also tells us p hat 1, p hat 2, but I'm just going to ignore all that. And now we come up with our conclusion. So we can say, I'm going to type this out. I'm going to say, since our p-value of 0.0136 is less than alpha equals 0.05, we reject the null. We do have evidence that the proportion, that's terrible spelling, proportion of plants resistant to the herbicide has increased from 2014 to 2017. There we go.